metal portion of an artificial joint plays the role of bone, while the plastic portion mimics cartilage. However, the plastic isn't your run-of-the-mill plastic. It's medical-grade polyethylene, meaning it's formulated to be lightweight but also extremely durable, so that it withstands years of wear and tear within the body. The type of metal they use to make the bone portion of an artificial joint depends on how flexible that joint has to be. A knee joint requires less elasticity, so they mold it out of cobalt chrome. A hip joint, on the other hand, needs to be more bendable, so for that they use titanium. They either forge the shape in a press or mount the titanium block on a computer-guided mill. Under a steady shower of lubricant, the mill's 20-odd machining tools carve the block from all angles. After a primary rough machining, the mill's precision tools finalize the shape. From start to finish, machining just one part takes about half an hour. Now a robot takes over. It runs the part against a series of sanding belts, their grits progressing from rough to fine. This removes marks the machining tools left on the metal and polishes the surface to a mirror finish. The robot can't reach the edges, so a worker sands them manually and verifies the dimensions. Then the parts go for a thorough cleaning. The factory puts random samples through wear testing. The machines simulate joint movement, complete with fake joint fluid. The factory sprays some parts with titanium powder to help bone tissue cling to them. This machine, called an optical comparator, projects an image of the part's coded outline against a technically perfect template. The technician makes sure the part and the template match. To become an artificial joint, the metal bone now needs its plastic cartilage. That requires polyethylene powder. A technician weighs out a specific amount, puts it in the outer sleeve of a mold, then inserts the mold's inner piece. The technician loads the mold into a press that applies both pressure and heat, 190 degrees Celsius. The powder gets squeezed between the mold's two parts and turns into solid plastic. Using various instruments, they measure the molded part to ensure all its dimensions are exact. Now a computer-guided machining tool carves the grooves into which the metal part will slot. These details are far too intricate for a mold to shape. Then some final measurements to make sure the finished part adheres to the engineering specifications. Random samples undergo fatigue testing, equivalent to 10 years of wear. Some plastic parts are just too complex to be molded outright, so instead, the factory molds a block of plastic, then machines it. The block spins on a lathe as various computer-guided tools shape it. Samples of these also undergo wear testing. After a specific number of movements over a specific time period, technicians remove the parts and weigh them. By comparing to the starting weight, they can calculate how much plastic has worn off. The packaging room is what they call a clean room, meaning the air runs through a filter system to keep out dust and dirt. Workers pack the artificial joints against foam to protect the metal surface because even the tiniest scratch can cause premature wear. After heat sealing the packages, the factory ships them off to a sterilization plant. There, powerful gamma rays penetrate right through the packaging and kill off any bacteria that might be lurking inside. Make no bones about it. These joints may be artificial, but the movement they restore is as real as it gets.
I don't never slow up, no I don't take shit, I got no love